Welcome to School of Chemistry. If it is your first time of visiting this channel, please click on the subscribe button. Today, we'll be looking at relative atomic mass. The intent of this class is that by the end of this class, we should be able to know what relative atomic mass is and also do little calculations on how to arrive at the relative atomic masses of elements. So the question is, what is relative atomic mass? The relative atomic mass of an element is the average mass of an atom compared to 1/12 the mass of carbon-12. The average mass of an atom of an element compared to 1/12 the mass of carbon-12. So what does average mass mean? From the study of isotopes, we have isotopes of chlorine as chlorine-35 with atomic number 17 and chlorine-37 with atomic number 17. Now looking at this, if we check for the atomic subparticle, we know that from the atomic number 17, which is the number of proton, the number of proton here is equals to 17. The number of electron is 17, while the number of neutron will be what? 18. In chlorine-37, the number of protons will be equals to 17. Electron is equals to 17, while the neutron is 18. When we create the average mass, when it comes to mind from the normal study, it is to take the average of these two elements, chlorine-35 and chlorine-37. And if you take the average, we are going to get 36. But that is not the case in the periodic table. In the periodic table, we'll see 35.5. So, the reason for that is because it is not just an average, but a weighted average. It's not just an average, but a weighted average. A weighted average is simply based on how common something is. That is the relative abundance of an element. How much of it is present? That is relative abundance. For example, in a sample of chlorine, you always have chlorine-35. Chlorine-35 is always present by relative abundance of 75%, while chlorine-37 has a relative abundance of 25%. What that means is that chlorine-35 is 75 times more common than chlorine-37. So it means if you are given a sample of 100 atoms of chlorine, you are going to have 75 atoms that are chlorine-35 and 25 atoms that are chlorine-37. This is the ratio in which chlorine exists in nature. There's nothing you can do about it. That is how it was created. When you see a sample of chlorine, you see 75% that is chlorine-35, and then 25% that is chlorine-37. So when you are going to calculate the relative atomic mass, or when you are going to express the atomic mass of such an element, you must take into cognizance this weighted average. That is why we talk about the relative atomic mass. So In calculating relative atomic mass AR, we use the formula relative atomic mass is always equals to the percentage abundance of isotope 1 multiplied by the atomic number or mass plus the percentage or relative abundance of isotope 2 multiplied by the atomic mass. Let's use atomic mass. It's a better term, atomic mass. Divide by 100. So starting with chlorine, you see that the relative atomic mass for chlorine will be equals to 75 times 35 plus 25 times 37 all over 100. If you do this correctly, you're going to have 3, 5, 50 divided by 100. And this is going to give you 35.5. And this is what you get on the periodic table. When you check your periodic table, the relative atomic mass of chlorine is always 35.5. Now do the following. Given the following data, calculate the relative atomic mass for the following element, following isotopes rather. Going to have boron 10 with atomic number 5, relative abundance of 20%, and boron 11 with relative abundance of 80%. Oh yeah, do it quickly. Or you get, if you do correctly, you're supposed to get 10.8. How do you do it? How do you arrive at that? It's going to be 20 times 10 plus 11 times 80 divided by 100. And that should give you 10.8 atomic mass in it. So that is how to go about the calculations of relative atomic masses. Now, in this class, we learn what relative atomic mass is, and we went ahead to see why we need to calculate the relative atomic mass of isotopes, and we'll try to understand the concept of average mass and weighted average, and we went further to see how to calculate relative atomic masses of elements from their isotopic abundance. That is it in this video. Thank you very much. In our next video, I'll be doing a reel on how to memorize or remember relative atomic masses of elements with ease.